Okay, so I've got the new camera now. This is a pan and tilt camera over here, so I can like run presets and have it just zoom into very specific spots and kind of preset up these angles when we're working, which is handy. And then I've got free control now to sort of move the camera around anywhere I want. So when we need to point at certain things, I can kind of align it up. I can zoom right the way in as well. So we can get to like 12 times optical zoom, and then we can even do like a digital zoom past that. So we can get, you know, pretty close. This one isn't quite as good as the Blackmagic camera in terms of quality, but considering I've got the freedom to easily move it around and have, you know, preset positions, I think this one works good for this camera angle. You guys just let me know if audio is working good as well and everything seems stable now, because I think it seems to take a little while once I start the stream to get it to actually stabilize. Morning, Josh. We'll be hopefully we might fix this other one fairly quickly, but we'll soon see. And we've got this is still the fully working one with the smiley face, so this is the only fully working Mac we have at the minute. The goal is to, I think we're going to probe this SCSI chip, so obviously we need to put that on first. So we're going to chuck on a SCSI chip on here, and then I think use the picoscope and just go around every single pin and compare them to the working one. That's the goal at the minute, I think. Let's try and figure out what's going on, because I do think it's probably going to be a broken trace. We've tried everything else that's not the SCSI chip, and the fact that when you put this chip on it fails, it just all seems to point to that chip. So that's where we're going to look today. So first thing I'm going to do is chuck this chip on. Make sure it's the right way compared to the other one. Yep, that's the right way. And then is the audio all good, Josh? Is it kind of coming through steady and solid, or have we got any issues with it? It should be all good. I haven't really changed much other than using Streamlabs, so we've got a bit more feedback and the chat's a bit easier. What I might do as well, just to get this on, is bring this in. Probably go to the side view, and then I just chuck this chip on. Plenty of lighting. See if I can get this focused to also focus in the overall image instead of my hand, ideally. It's better. And this chip has come off the known working SE as well, so we know these SCSI chips are definitely good. It's not the actual chips. That's that chip on. slight cool down on them. Yep, got one there. Let's just check that's soldered well. We should be able to do that with this camera now. So if I get it in focus, see, I could do with keeping it in the air if possible. That's as close a focus as I can get. So like there, we can punch in on that, and then there you go. That's a non-microscope view of the pins. See, they're all soldered nice. And then it's just these ones don't look they don't look soldered on the visual there, just because of, I think, the angle of the camera. So let me just double check them on the scope as well. It always looks like that due to the angle, I think, of where you're looking at it from. Yeah, they're all solid. So that's the SCSI chip on. So let's now just confirm. I have confirmed that if you remove the sound chips, you won't get sound, which we don't need. And we can boot without this. So I did confirm that on the working one. So I know these missing won't cause a problem. But now we don't have to keep messing around with changing the chips over. So let's just first boot the known working one. So I should be able to pull this back to that position. That works good. And let's just try. Always like to make sure everything's working as we last left it, because things can change overnight, just leaving it. So this one booted to the, well, this is basically a full boot, but off ground. There we go. So this one still boots. You still get, let's bring that into the center. You still get your cursor. And I guess we could connect a little bit. I think that's that flickering is the high voltage PCB at the back. I'm not going to touch that. Let's just probably, well, no, we don't need to see this full boot. We've seen the cursor. So this is the working one. So we know the power setup's good. This is what's a bit dodgy. I think that's what keeps making all the crackling. Like this is this extension is not the best quality. I'll probably have to, in fact, I think I can see what it is. It's that pin coming out. So this end pin is actually pushed out. Yeah, and not even in right and bent. So good quality extension. And see if I can fix this before we carry on. Otherwise, that's going to start becoming a pain. Yeah, so I'll just get yet another extension. Yeah, we've got a Mac SE30s on the bench at the minute, tons of them. Right, so this now is where we get nothing, or, well, if everything stays exactly the same, you get boot and absolutely nothing, which is exactly the same case. And obviously reset no longer works because we've taken out the sound chip. But we're back to, this is the issue we have on this one. That is definitely going to be a pain, that connector coming in and out. Yeah, so known thing. So let's now get the scope out and take a look at what's going on. So we might want to, I think really we want to probably start this off. That is really going to become annoying, that popping in and out. We'll start off diagnosing the working one, like taking a look at what happens on the SCSI bus and try to remember what happens, and then bounce between the two. So we don't so much need this in the way. oh no, there's no difference there. That wasn't jail bars. That's, I've swapped the RAM out. So you just got the other version of RAM. So that's still effectively your jail bars. There's no difference there. The only good thing I mentioned yesterday was I resocketed all these on the, well, I socketed, not resocketed, all these chips on the working one, the fully working one, and just literally taking these off really carefully as I do and as I know how to do. One of the traces inside the PCB got damaged, so one of these internal traces damaged, and it was definitely not from, you know, like excessive force or anything. It was hot air. It was the silicon tipped desolder pump, so I did it really carefully, no issues at all, and it still made a trace damage. So I think the old boards are very susceptible to trace damage even when you're careful with work. So that's what kind of makes me think there's hope for this board. It probably is just from swapping chips out. We've damaged one of the traces inadvertently, so that's what I'm holding hope for there. So let's just grip on this, power this board up. So this is the no, wrong one. We want to start with the working one first. So let's pull this camera back a bit so we can see. Pull over a bit. See, this movable camera's quite cool. And then what we'll do is power up the working one, turn, and yeah, that's a really bad power connection, that is. That's definitely not going to help with diagnostics because this one doesn't boot without them resetting after due to that unstable power, so that is not going to help us. We can now do probably overhead and get focused on that chip. So that's the chip we want. And then we will overlay the PC on there. That's it. Open up Picoscope. And we should be able to just probe around all these pins now, and we'll see on the scope what's going on. So we'll pull them over to there. Get this set up for pretty standard output. And now, while we go on, we're not even bothered about what the pins are. We just want to see what they're doing. So if we put a measurement on, so we can see the top. So there you can see we've got a 5 volt. So you can see where the line is. Basically, if I drag a few lines down, so when you remove, you can kind of see where they should be. So you can see a faint line here. That white line is where that last signal was, and you'll tend to find there's a few points where signals end up resting. So that one's high, that one's low, and we just have to try to remember these. So you can also do like on power cycle, if we put a trigger, you'll pick up any pulses that happen. So see there's a pulse on boot there, so you get a tiny little pulse, probably lower it to 20. So there's that pulse. So we know that first pin basically pulses and does that on boot. And then second one, that's just a flat down and then rises up. Third one, just flat. And again, these, we're not going to remember all these, it's just to get a feel for it, and then if we start suspecting things, we can look around. That one's permanently up. Permanently up. And you'd expect activity on this as well when it boots somewhere, because it should be hunting for a SCSI device, so whether it's just immediate, so there you go, there's some hunting going on. So we're now at pin 1, 2, 3, 4 from the bottom, we start to see permanent activity. And you'll notice, if I pull up the PC on full screen so you can see, you'll notice the height here is a bit lower. So I'll drag another cursor down, because that's what happens with CMOS chips. You'll normally get that the data and address lines almost sometimes look like they're bad, because there's all kinds of soft waves and things going on, but that's the buzz control and the way the CMOS works. So this drop is likely, you know, reverse diode protection inside the CMOS. So that's the expected level on a working system. That's the next pin, and you can see again, if I put maybe a filter on, probably 4 megahertz or something, get rid of those spikes. So you can see a bit cleaner now that those are, even though I'm filtering out high frequency signals, if we turned it off, you're going to get this spiking, which is, you don't want to see these ringings. It kind of interferes with your visual. It's a bit easier to see if we put a filter on, just to be able to visualize the highs and lows, which are more important at the minute than having all the signals show. So that signal's the same. That's the same. So far we have a bunch of signals here that are pulse on start, high, high, low, high, and then you start getting activity on the 4th pin carrying on down. So this VIA is the start of the pulsing. So we can kind of remember that. And then we will, to be honest, we'll probably stop and do that side now on the other system and just do one side at a time if we can. And then we've got a much better chance of remembering what's going on. And we may see that the activity is completely different to start with. What I'm looking for, though, is ideally a broken trace. So if we try and hold this in, because in fact what I'd have to do is push that in and then I'm best. Yeah, that's a really bad I can't believe that extension's come like that. In fact, 1 second. I can probably rob the cable out of one that's been, because this is a standard ATX power supply cut up, I can probably rob out of this one. So let me just turn that off a minute. Just try and quickly repair this cable that's really annoying, because it's going to definitely interfere with the testing. And we have to, so you have to try and get tweezers in. I think I do have the proper tools for doing this, but I think if my tweezers weren't quite so fat, I could probably do this with tweezers. Yeah, we've just got to get them wings to flatten. Yeah, we should be able to. If not, there we go, got pointier ones. Maybe these will get in. No, I'm not going to get in there with these, that's a shame. Yeah, there we go, just push one side down, worked. Right, let's see if now we can swap this with a decent one. So we want pointy side in here. And luckily, for putting them back in, you just have to push them in. You don't need to use the tools. So we should be able to just get that back in. Didn't expect to have to do a repair on an extension lead I've only just brought, but there we go. This does not want to go in. No, because these are offset apparently. So some pins are offset, so I've pulled one out that's got a slight offset. I didn't even know that about them. So let's try pull another one out. How are they offset? That's weird. I think one's just been bent, to be honest. That shouldn't be offset. No, it's just, have I pulled the only pin that's actually gone offset? I think I have. I'll have to show you after Yeah, this cable's literally come. I've only used it twice and it's already faulty. So just wants me to fix it for some reason. Yeah, so the middle 2 pins of this extension have like an offset on them. So there's no way it's bent. They must be factory like that. Let's try getting to pull another one out. Because it's going to make the job 10 times harder if we're trying to boot this up with obviously an extension lead that's also intermittent. That's just going to add to our problems. We definitely need stable boot. Let me just try and cut these out. I do have all the, like I say, the Molex tooling. It's just in the garage. I can't be bothered to get it. I'll just hack my way through this for now. And this is just the, obviously the other half of the cable that we don't use, with the Mac being like just a half-sized one. So hopefully this one's straight. Yeah, that one's straight, so that'll do us. This side we should be able to do what we did on the last one, hopefully, and just get that tweezer in there. If not, we'll just cut this one out as well. No, just wants to be cut out. So, flat should now go into the flat without problem. Now it's not bent. There we go. And this one should go into here. Yeah, I think the old, quite a lot of them did that, didn't they? They reused all the connectors, like all the DC power jacks. Right, there we have a hopefully fixed connector. But it was worth the time, because hopefully now this will just plug in and work without keep failing. I've got the wrong end here, not the right end. Flat, down, curve. That way. There we go. Turn on. And let's see. No, so what it is it isn't technically standard as such. I think one of these pins in this board is slightly bent, causing it to not plug in as easy, and then push that out, because that's pushed it straight out again. Or this plastic housing is not holding it in. Yeah, it's the plastic housing, so this housing's bad on the connector. That's quite annoying. Let me just Q-bond it in place so it can't move. And then at least we can use this and it's not going to be able to push back out. Turns into a ATX extension cable repair video instead of a Mac one. Alright, so it's that one moving. Hold him over. I'm just going to bond in. I think even without the cabling, you can move this up and down fairly freely. So I think it is just this connector block. They are meant to go in firm, and they are a bit shit as it is. So the hardest bit's going to just be getting this initially somewhere in place. So you have to build up a pad first of Q-bond. Yeah, there's definitely a lot of movement on that shouldn't be on there, really. Just gotta hope we don't glue too much of this cable in, because that'll be the next problem if we glue over the connector hole. There we go. Just make sure that hole stays free. I nearly brought 2 of these as well, because whenever I buy anything off Amazon, I expect them to not be good quality as it is, but this wasn't exactly a cheap extension either. It was like £10 just for... I purposely picked one that was a bit more expensive, presuming the quality was going to be better, but obviously not. Let's see if that's any better. Yeah, I think that's better. Covered in super glue now, but seems to have done the trick for now. Made it absolute state of the desk. Right, that real quick patch-up job done. Let me just at least partially clean this desk. That's crazy. Absolutely covered in super glue. So one thing on these mats as well, I have to buy new mats anytime I use super glue, really, because it doesn't come off perfectly. And then if you use acetone, you tend to eat through the silicone, discolour it, so hopefully I can clear this off later. That'll have to do for now. Partially super glued desk. Right, so now we have a better connection. Let's get back to where we were, which is over the top. We want the scope going over, and then still running. So we can't do the reset on this at the minute easily, because we don't have the reset switch. So we're going to have to do that to see. Absolutely no activity on there. None on there. We are working. So the first 2 pins that were high, we're getting literally nothing. So nothing on there. Nothing. Nothing. high. So the first three are nothing. Let's just see if they actually do anything on power cycle. Nothing at all. So this is not looking like a broken trace, unless all them are broken. It's more looking like something that's preventing boot, maybe. And that one's high, which I think it was. That one's high. That one's low, which it wasn't. So this is nothing at all like. And these were pulsing data. So these were seeking info. That one's held at like 0.2 volt. So that's sitting at just above ground. So the other one I'm sure would have been flat. So this is inactive. Let's just try power cycle. Yep, never comes up. There's just no activities. This is almost like the SCSI isn't doing anything. So there's no way there's that many broken traces. Let's just probe around, see if we're getting any activity. And this is what I think. I don't think we're even... No, the SCSI isn't even being activated whatsoever. So this one's going to be a bit deeper mystery than we thought. I think reset pin is 3, 4, 5. I think coming out to reset here. If I'm correct, I think that's the reset pin. And we don't even come out of reset. So, putting the SCSI on holds it in reset. Why? When there's no activity at all. Let's try some data pins. Just see if we've got any activity at all. Let's just zoom in a little bit. So this board, as we see, just seems completely dead. I think what we're going to have to do, so we can at least press the reset button and see things, is let's just put, I know I said we didn't need to, let me just put this sound chip back on, and just move that down. We're going to put this sound chip back on here, and the sound chips inside, just so that we can press the reset button, because this is going to be vital in terms of testing this one. I've got a K12 spare there, so that means the other one doesn't have them on. So I'll have to rob this off this one again. This is definitely the pain with having this one sound chip between the two boards. Just so much extra work. Yep, just check UB11 as well. I think UB11, I'm pretty sure it's pin 5 is reset. Oh, actually, saying that, just go on retrosix.wiki. I wrote down where the reset pin goes. I think all the pins to every chip, but mainly the sound one I'm just interested in at the minute, because that's what we tested when we were seeing if we were able to reset was pin 5. So if I've got that wrong, yeah, that's right. So we definitely stuck. It could still be a broken trace, because what it could be is if one of the traces is dead on boot, we get a very quick address and data attempt. Something's corrupt and it goes into reset. So just because we've probed half the chip doesn't mean we haven't got a broken trace, but we're going to definitely need this. We're going to need the use of the reset button to be able to probe this much further anyway, because we can't reset the console by, power cycling the power every 2 seconds. So I think what we'll do is we'll just blind probe every pin on the SCSI to see what I'm looking for really. If it is a broken trace, as you'll normally get like a half voltage signal, like a 2-volt signal, or you'll see something floating where it shouldn't be. Where it's hard to explain, but it's fairly distinctive to see. Once you've seen a few broken traces, you kind of know what they look like. Surprised none of them caps exploded in my face. Zoom out a bit. So this one now should be able to be turned on, and the reset should work, so we should see the screen flicker as well. And then we know the reset button's working. And I think we just probe all around. I'm still semi-confident we've got a broken, well, almost confident we've got a broken trace, because mainly just nothing else makes sense. The system fully works if you don't put the SCSI on. It's like, the most obvious cause, which, with how much non-luck we've had on these, it'd be nice to think at least one thing on these has been fairly easy and obvious, but it actually does turn out to be something that makes sense. So we do that this way, that under there, and then overhead. I'll probably zoom the overhead out a bit. I think we're a bit zoomed in. We can see a bit more. Right, so that is now. Just let this cool down a minute. Pin 20 on SCSI, let's count that as well. So 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So third pin in over here is the reset, but let's do a quick continuity check, just make sure we've got, well, we've got to have reset because it's holding it in reset. Without it, we're not in reset. So you'd say we'd have to have continuity. Let's just double check that. Third pin in. No. What? 1, 2, 3, 4, 5. Let me just, as soon as I swap camera angles, I realise you can't see the thing I'm looking at. So what I'm probing at here, let's get this into view and zoom in. Make use of this new fancy camera. So I'm probing pin 5. 1, 2, 3, 4, 5. So that's pin 5 of the sound. We said the SCSI was pin 20. It's not. But pin 1 and 2, well, not pin 1 and 2, pin 7 and 8 are short into ground. So either I'm doing something that's fairly obviously wrong, which is more than likely the case, or that's a very bizarre thing. So 1, 2, 3, 4, 5. No, so you see, the SCSI has, but there you go. So the first pin is going to ground, second pin isn't, and this is no power applied. So that is obviously pin 1, 2, 3, 4, 5, 6. Pin 7 is going to reset. Pin 8 isn't on the working board. But on this board, let's just double check what we've just done. Pin 1, 2, 3, 4, 5 on there. Pin 7 is reset. 8 is reset. Now, that might be with and without this chip on, but there's a problem. So schematic time, because none of that matches what we know about the schematic so far. Twitch has dropped again, has it? This is a... I wonder if it'll kick back in. If not, we should be live. Let me check on my Twitch, actually. 1 second. Yeah, now I think it, to be honest, I think it did this the other day. I think Twitch didn't stream video, so I'll have to look into that. Let's check YouTube still live. Yeah, YouTube's working. I think Twitch did this yesterday, to be honest. There's not many people on, so Twitch and Kick aren't streaming correctly, so I'll look at that after. But for now, you've got YouTube mainly as the stream that's working. Right, let's go over to schematics. And we are looking for... what are we looking for? Where's the SCSI? Is that page 6, I think it was? UI12, yeah, so the SCSI's here. Oh yeah, so pin 7 is reset. Now, there you go. SCSI IRC is grounded. That's the problem. Well, I say grounded, it's shorting to reset, so... that actually is fairly simple and makes sense. Realise I'm not even showing you this. So, pin 7 is reset. Pin 8 is IRC, and this one is joined to reset. So hence why if there's no SCSI chip on, there's no problem, because the SCSI never replies, so nothing really happens. Whereas when the SCSI's on, and this tries to send it high, it can't do anything and hangs. So we have... we're just going to have a short somewhere between pin 7 and 8, that's all it's going to be. So... wow, probably should have... well, this is where sometimes you'll scope all day and never find the answer. Other times you'll not do a visual inspection and there's just a join somewhere. You can never guess what you're going to focus on first, but this is going to be a fairly easy fix, hopefully. There's only one other place it goes, which is page 4, SCSI IRC, which I think if I remember right, the page numbers don't match page, so I think it means this page 4, which is page 3 in the schematic. And it's the glue chip. And it's SCSI IRC, but then this says it goes to page 7 and 8. So how does it go to page 7 and 8 here? Oh no, I'm doing the wrong one again. SCSI IRC versus... this is the one we can never see, isn't it? We look and look and look and can't spot it, and it's right in front of our faces. Yep, I'm going to do it again. So, where is SCSI IRC? We did this, literally this is exactly the same thing we did the other day, and I had to open up the other schematic to see it. Unless it does mean this page. Like it does actually mean page 4 in the PDF and not page 4 on the schematic. SCSI I... yeah, so it does. It means the page numbers then on these ports. So see how we've got like 6, 7, 3. So see this SCSI IRC here 6. Well, you look at the PDF page, this is page 4. But if we go to the page number of this page, this is page 5. So then if we say, well, it's telling us the SCSI IRC is on page 6. If we go to what page 6 is, it's here. This isn't the page it's on. So there's no SCSI IRC on this page. It's actually page 6 of the PDF, which is a bit strange. They've got the page numbers completely messed up, really. And then if we go to here, you've got SCSI IRC. So page 4 is there, and it tells us it's also on page 5. So well, it's on page 4. You go to page 4, and it goes to here. So we're looking at the VIA2. That's the only place it goes. So either we have a short that we've overlooked, even after swapping the VIAs twice, which is unlikely, or something else is going on. So I can't imagine this being this simple. I think there's a... Did we remove the... Well, let's look at the chip first. But I'm thinking, if we obviously now remove the SCSI chip, see if that short's still there. There's no way we have... Ugh, nasty sound. There's no way we have a bad SCSI chip twice. This is literally the one off the board with the smiley face written on. So I just can't see it being that. So VIA2 is what? UK11. So we're looking at this chip here. And pin 20, was it? SCSI pin... where is it? Yeah, pin 20. And pin numbers are completely missing on this. I presume that's pin 1. Has it got that diagram that shows us the pins? Yeah, it has. So pin 20 is, if there's a curve there, a notch there, 18, 19, 20, so third pin over. Yeah, there's absolutely no short on there, so I'll show you that. Jump onto there, jump onto zoomed in. This is the one we're looking at. Pin 20 is the third one in. There's no... Get some more light on there so you can see. Nice bit of light. A bit too much light there. I think the camera actually prefers it without the light. A sideways light. Right, so there's no short on any of them pins, and we've swapped this twice, so I wouldn't have expected it either. Goes to UG12, does it? Doesn't say on the schematic it does. Not according to the port numbers that I wouldn't trust anyway. What page is UG12 on? Oh yeah, no, so it's the only place it goes then is where am I now? We have the SCSI Icon here, second pin up, and it goes to the third pin down here. That's the only place it goes on the schematic. So I think we're going to have to take this back off again, because we need to know whether, I mean, this is where I'd say 99% it's not this, because that's the whole point. We've taken this off the working board, we know it isn't this, but again, let's just ignore logic and take it off, because it's telling us that basically what this could be is similar to what I've seen in the Game Gear, which you wouldn't believe happens, but you might have where this trace goes to, I presume, an inner layer here. The inner layer trace shorts to ground, or shorts to another trace in an even rarer circumstance. Normally it'll short to like a power plane. So we could be dealing with that. You do get it in Game Gears, that's the only reason. I know it's something that can happen that you wouldn't believe. The VREF circuit can have, and it always seems to be the same pins as well that end up happening. The ones near the diode end up shorting to the internal ground plane, but only partially as well, like, you know, 10 kilo ohm short. So that's one of the problems with old multi-layer boards, I guess. And we can even remove the VIA if we have to see. And again, this can't be faulty. It's got the tick on. We took this off the working board that fully worked and fully booted. Same with the SCSI. The SCSI's got the smiley face on. So there you can see the smiley face. So this has come off. Both of these have come off the working board. So the theory tells us the chips can't be bad. But then this was also originally, when I brought it, a working board that's magically, I think, developed a short or something going on inside. And there's no way, well, I say there's no way, things can be crazy, but I've hot swapped this chip on, 4, 5, 6 times now. There's no way I'm magically getting a short between them two pins every time. I wouldn't say. Yeah, there you go. So the short still exists between them two pins. And just for sanity, let's check this board, and not only this board, we'll check the other one as well. So yeah, nothing there, but if we touch pins, obviously the sensor works. Let's get them reloaded. Oop. Things about. And then on the reloaded now, this doesn't even have the chip on. Let's just confirm that it's not a revision thing. No, so this is the problem. So at least we should solve this now. Right, we're at this one then. So last step, we're gonna have to take this VIA off as well because we can't trust this now. And I doubt it's going to be that, but at least if we've removed these two, and the schematic says that it can only be a connection between these two and we still have a short, we'll just sever the trace and run a jumper wire and ignore the fact that there's obviously going to be something internally shorting these traces together. And luckily, if it is joining to the reset wire, the fact this trace, the one that's joined to, only goes to here. By severing it either side, we know it's also not, going somewhere else and going to cause further issues. It would be nice to see, again, that remade schematic of this board, so we could have seen visually in like KiCad where the traces went. That would have been perfect for this, and then we'd even be able to detect where potentially that trace shorted out. So that was something completely unexpected. Temps for most things, like a lot of things, I use 470 degrees and 80% airspeed. This I'm using 490 and 90, just a bit hotter for now, just for I want to work a bit quicker. And I've got a bit of confidence in, working on this now. With the more you work on certain boards, the more you'll get familiar with what temps work best. But if you're unsure of anything when I first start on a new board, unless flipped IPA in my eyeball, 1 second. Unless it's a really thin board, like a 1 second. I always say what they are and never show what they are. So let's go to side cameraman. So this is an Atari 2600. See this paper board ultimately, single layer. So that's literally a single layer board. Even this is a dual layer, but this is paper. So if we go over to the top down, this has got a paper composite between, but effectively you might as well think of it as paper. So see how it's just, if I get tweezers, in fact that actually might be fiberglass, but it's a weak fiberglass. Normally these are paper, like a very weak circuit board, whereas FR4 is fiberglass. So I know these, for example, these boards are not heat tolerant at all. There's also no ground plane, so for these I'd be running like 420. But it's one of those things you just learn with experience with your tools as well, what you're comfortable with. But unless it's a very low temperature board, 470 at 80% is a very good universal starting point. And then PS5s, Xboxes, modern consoles, I just max out the hot air because they're just that thermally conductive and designed to remove heat. Obviously they need it sometimes as well, otherwise you sit there forever spreading heat all over the board, which you also don't want to do. You want to limit the amount of heat going everywhere. Right, clean this up once more without getting IPA in my eyeball. Right, this is the one we're trying to fix. So now let's just do a visual inspection, make sure there's nothing on this. So this time we'll go. I've got as well, this lens I'm using is one of my crazy expensive ones, and it can actually digitally zoom, but because I've got a Blackmagic Studio, it's an old version of the thing the lens attaches to. It doesn't have the software to control the lens, so I've got to spend like another £1,000 just so I can move the lens in and out without using my hand. So for now, I'm using my hand. Right, so look at that. That's just from the lens as well. It's crazy. It's like a microscope. Yeah, just clean these tools. Yeah, this I definitely wouldn't recommend this. I think I said it before as well. This Steri, I love the Steri fluxes, but this ASM is sticky as shit. Like, I'm always cleaning my tools. I noticed it yesterday. I've just changed to it and just working my way through all their fluxes to see which is best. And I thought maybe yesterday I just wasn't cleaning my tools, but this is, yeah, everything's sticky again today. And I know how I clean, and it's normally cleaner than this, so I think that flux is sticky. Right, so this pin and this pin are shorting together. Let's double check, actually, we've taken off the VIA. Let's see if this is magically gone. I hope not, in one way. Yeah, so we are 100% dealing with an internal board short. So these two pins are somehow joining. I can't see any join there. And they go over to the VIA, third pin down. So third pin down here. And that's according to the schematic that says it's pin 20. And that's the only place it goes. So this dot is 1 and goes around. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this pin is shorting to reset. So let's just double check that as well. That over this side, we're shorting to reset, which we are. So we know the problem. Where is reset on this 37? So you see on this 37 is reset, which is, let's see, 28, 37, 39, 38, 37. So this one and this one should be joined. So it's unlikely going to be here because these two vias are miles away. But if you look at these two vias, the most obvious places, these two vias, what's probably happened is these two vias going through the board have simply broke down in between. So I can almost guarantee you it's going to be that via. Like if I blow that via away, so the pin isn't connected to the via, well, it will because there's just a pad there that is going to disconnect it. But I reckon that via is where it's gone through the board and it's tracked internally. So let me just see if I can pull up. Might as well explain so you know what the problem is and what I'm thinking. I'll just get rid of the schematic again and via internal PCB visual. See if I can show you what I'm talking about. Right, so let me just zoom in. Nearly got it now. I'm just trying to get a decent picture. I think that's about as good as I'm going to get. Close. Right, there we go. We go to PC. So this is what we have here is, see these two, say these two vias are just like the two vias on. I wonder if doing that is going to give us enough visual. Yeah, you can see that better. So now, say these two vias here, or these three vias, are like these, well, I can't point over the screen, but those two vias there coming down. As they go through the board, so as they travel through the board, this is the hole you see at the top. This is the fiberglass of the circuit board. This is the multi-layer, because funnily enough it is multi-layer, so in between these two, this is where you'll have the power and ground planes on the Mac. This is the underside, where you flip it over and you can see. And then they basically drill a hole through, so that's a hole through the board, and then they plate the inside wall of the hole with copper, like this. And then as it's travelling through the board, if they want to break off to another layer, they join onto that ring. So what I think's happened is, this bit here, this insulation, this little green, as you're travelling through the board, I think, let's presume it's like this, where there's nothing at the side. I think this has broke down, this fiberglass, say on the inner layer here, and these two bits of orange, these two copper bits, have shorted out. So that's what I think's happened inside this board, basically. We're going to go through the board, and if we blew out this via at the top and bottom and rejoined it, I can guarantee we'd fix it. So what we could do is disconnect the via at the top. So if we go back to here, what I'm thinking is if we zoom right in, if we disconnect this via right here, so it doesn't connect to this pad, this via will still touch that via, but then if we flip the board over, we're looking for 3 vias in a row. I think it's, oh. You're going to love this. Let me zoom out. Occam's razor strikes again. Look at that. What do you see there? Something you're never going to pick up on. The two vias are shorted. But visual inspection, you wouldn't really notice that unless you're looking very specifically there. And that also, just to point out, I don't think that's something I've done. That looks like dry leaded solder. Like, I wonder if there's another problem with this system. And that's why they've done it now. But either way, maybe I have done that. But there's your answer. So it was a literal short on the vias right underneath. So that's a nice easy fix. There we go, nice and clean. And that, I can't even tell you how many hours we've been trying to fix this one, on and off. But that's where diagnosing it this way is probably what we should have done to start with. So let's put on, I guess we'll just chuck these two chips back on now. And then I'm pretty sure that's now going to make it work. So at least that's this is where scoping things out can help you, but also a lot of the time it can also make your job longer, because it's not always that simple. You have to really start understanding the circuit to do what we're doing here. And at the minute I don't have that much knowledge of the Macs, so scoping around, we were pretty much scoping blind, and then just, I don't even know what made us check or even start there. We just started at the top, and I think we were more lucky there to find that issue so quick than if it wasn't there, or I would have quite easily overlooked that. Like when we just took a look on the scope, I said, there's something else wrong, it's not doing anything. I had no thought that those two pins would be shorted. So I think we were just more lucky there on that fix, but I'm very confident this one will be a full boot, and that'll be 2 Macs out of 3 fixed, and then we can focus on your last one, Josh, and hopefully we can figure that one out, because that one's done a similar thing. It's just even worse, it just completely died, but we should be able to get it working now. We've got 2 fully working ones we can compare to. Well, I say we haven't proved it yet, but I'm confident that's the issue. Ooh, hot. Oh yeah, you're not wrong. Apple are the worst for supporting repair. That's where I literally used to watch Louis Rossmann before he did all the political stuff. That's where I kind of got into chilling and watching some soldering. So when you do it yourself, it's not as enjoyable. You've got to think about what you're doing. But when you sit watching other people do it, it's quite enjoyable. But I think he's obviously he went into all that right to repair and right to restore. But now that's all he does. I think I don't really ever see him doing any actual Mac repairs, which is a shame. Yeah, I think I've obliterated my desk with that Q-bond and super glue. Yeah, I'm going to have to buy another Mac, because that's going to drive me nuts. The last one is the VIA chucking back on. I can probably move this camera as well. I'm tempted to move the camera over, like over here up to the top, so you can get a face cam and a side cam, but instead of looking at me from over my shoulder, you'll be looking at me from forward. I don't know whether that'll be a bit weird, but I might try that camera angle for the next one, because then we've got a kind of a face cam. Then you can also track, this camera I've got can track subjects. It's quite cool, whereas at the minute all it's really doing is pointing over my shoulder and not being used that much. It's got all kind of AI tracking built in, and I did test it and it works pretty cool. So we can just have it tracking my face while I'm working, and then when we want to look at something on the desk, I can just move it with a remote control. I know what's happened on this as well. I've just realised I know exactly what will have happened, because I've never even touched the bottom of this circuit board with a soldering iron. But I'll show you what's happened in a minute. Well, what I'm pretty confident will have. Because I've seen it before. So I definitely know what's made that happen. I can probably do it again, but I'm not going to for now, because we don't want to do more damage to the board. But I'll show you in a minute how that's come about, and it will be me. That's what's happened there. When I've swapped chips between this board and the reloaded board, I know exactly what's caused that now. Right, so while that's cooling, let me show you what's... this is exactly what went on. Like Sherlock Holmes. So, when we have... where am I? I can't even find myself on camera. There we go. When we've come to take this chip off, because we had a SCSI issue with Josh's board, I've taken this off mine. I've retinned these pads. And what's happened is... I don't want to do it just yet, but if we're retinning these pads and these vias are not tented, so they're not covered over the top, that's why you can see solder. Let's do it on these two, say. If we were tinning these pads around here and we were catching these vias with extra solder, if you put extra solder on them vias, like this, so this is what's happening when I'm tinning the pads, I'm going over them. If we now flip the board over and look at them two vias, you can see that, where are they? See those two vias, how they've started to gain extra solder on? So they've bubbled up a bit compared to the flat ones next to them. Like these are flat and you can see the dimple. Those have started to gain solder on. The more solder you put on, it's going to come through the via, fall out the bottom, and because these are so close together, they've naturally shorted together. So what will have happened is, I'll have been applying solder to these pads and the surplus has gone onto these vias, seeped through underneath and shorted. So that's why modern boards, the tent the vias, which is basically covering them in the green silk screen. And have I got any circuit boards? I've got like a baby one here, so this is one of my little products. And see all the vias, see the little dot there? So if I get this tweezer, we have the little dot, film on, a little dot here, and a little dot here, so see them in the light. They're covered in the white silk screen. So the whole point is then when solder's on these, it doesn't flow into them and it'll flow to the underside. So this is called tenting of the vias. That's why we do it, to prevent exactly that kind of issue. So, moment of truth. Do we think we've got a working board? I'm that confident I'm even packing up my equipment. Let's make sure this is in view. There we go. Turn on at the back. And we want to see the cursor, basically. You watch, we won't see it after I've said all this. Yeah, there you go. Cursor. So now, do we get full boot? And probably turn it off properly. Put that in. And this should fully boot. And then if so, we've got two completely working Mac SE30s that I can break another day. So we want to see the happy Mac, otherwise we still have issues. But the fact we got that far now, I'm much happier. Don't think it's going to boot. I think that should have booted by now. Wonder if the cursor will work. Oh, yeah, so it's failed to load off the drive. Let's see if cursor works. Yeah, so mouse is working. Move it around, reset. Now I can't hear the hard drive. Ah, there you go, hard drive spinning up. So maybe I haven't really checked my soldering on these. Yeah, RAM. Well, we did a full RAM check on this. We've had this one fully tested. This is that one we did the full test on, where we checked everything. If you remember, where it was the 30-minute, 40-minute test of RAM. So everything else passed on this system before. So it's probably just me soldering. I haven't looked under the scope. Too excited and too confident in my work. So let's just check. I've probably just got a missing pin or something. Is my thought. Just not soldered well or something. Or we may even have another one of those bridges. Oh, that looks all good. That looks good. Yeah, that soldering looks good. If it's delaying boot for RAM test, how come the other one doesn't seem to delay boot? You know, the working one that just seems to kind of rapidly boot. Or is that what you're saying? You think it's you think there's something just wrong with the RAM? Yeah, the soldering is good, so there's no issue with soldering. So let's just try, removing these, because to be honest, I don't even know whether this RAM is good. Let's take the RAM. Well, let's first go back to checking everything. Let's boot the known working one. Let's check the hard drive still working and that nothing's changed. And oh, I think maybe that being out again. There's another one. There's my Q-Bond one. That's fine. Another one's come out. This extension lead is crap. Was that the issue? Were we missing just a power connection? But let's see. Does this one boot? Oh yeah, I suppose as well it's got to have passed the RAM test though, because it would have failed to. You would have got the. Actually, yeah, I presume you'd get the sad Mac face, wouldn't you? If it failed RAM test, so I don't think we're looking at RAM. Couldn't make this up. Now the fully working one doesn't work with the hard drive. Has the hard drive just stopped working, or is it this extension lead? Is this extension lead just bad with all the cables coming out of it and that? Let's plug this in. It's just about fits doing this as well. This is really difficult. Can't believe I brought the extension cable and it's even falling to bits after one day. Right, it's just about in, nothing shorting. Let's try without the extension lead. Yep, so hard drives magically died overnight because this is the fully working board we haven't done anything with. I think the hard drive is sticking because it's now making noise again. Like, not enough noise. It was clicking before. So I do think we're just dealing with a bad hard drive on both of them. So we could do with a new hard drive, but I'm pretty confident it's now doing what this one's doing. I'm sure we've fixed that. It's just a shame I can't get it to now boot into Mac when I know for a fact it works. Let's try full power down. I can do with just remaking the hard drive as well. It's just a bit more research and time, and then I can make a hard drive, or just a working blue SCSI would be good. Shall we just try that SCSI again? I know it wasn't working before, but I might as well try it again. So it was nothing to do with the extension. So we can move that out of the way. Let's zoom this out a bit more. There we go. Let's get this extension back in. But this is what I mean with the Macs. It's like literally fully working hard drive. Nothing's changed overnight. And it's now the hard drive's dead. And we literally haven't taken anything off these that I know of. I think I've swapped these around to confirm they work though. But either way, we know we're not dealing with anything other than potentially swapping them chips around if so. And then we're in. We've got the Pi SCSI. We've got the power. Let's go. Right, so you think just maybe leave this on screen, even though we're getting the question mark. I think just wait. Yeah, so now it's kicking in on the lights on here are changing. So maybe this is perfectly fine. Yeah, the lights on the transceiver, there you go, happy Mac. So this sitting overnight, hard drive dead, wicked. Welcome to working on Macs. Even back in the day, Macs seemed like they were terrible. So is that normal though, happy Mac and then question mark again? Or do you think that's a problem still? But we didn't see the happy Mac before, even on the hard drive. I'm forgetting as well the where's my mouse gone? Oh yeah, the hard drive image is corrupt. I think we said that, wasn't it? So we'd have to redo the image. But looking at the fact we got the happy Mac, I'm pretty sure. Obviously, we fixed the other one because we get the exact same symptoms now. We'll just the happy Mac and then flash, and then that's where we said, wasn't it, that the image is corrupt? Yeah, so that one's fine. I forgot this whole time. TikTok chat doesn't come through. Let me just flip back up in case people are still watching. Someone's saying there's bad echo on the audio on TikTok. Hopefully there isn't now anyway. There's quite a few people on there, so hopefully not. Somebody wanting to see the NES cartridge pin connector fix. I think I've got a few videos on that, but I could do another one at some point when I next get one in. To be honest, that's not that far away. Does the inside of the case have an autograph on it? Not that I can see anywhere. Don't know where I'd be looking for one. No, I can't see any autograph on the case. So I think we're just dealing with this Pi SCSI image we can obviously redo. But that's been a problem from the last time we fixed it. So that one, we know this one works anyway. This worked yesterday, and it's just that hard drive's now died. So we know already this is fully working. I'm pretty sure now the one we just fixed is fully working. So let's do exactly the same test on this one now. Let's put that RAM back in because obviously the RAM must be working. That's why it took so long to boot. It's not also, you might know this, Josh, but it's not the fact that other system doesn't have enough RAM, is it? So instead of, it normally says, oh, this needs more RAM. I've seen that once. Would that image just literally crash because there's not enough RAM? Like, just come up with a question mark, that might be a problem. And in fact, that's what the hard drive originally said, even though the hard drive's just not working at all now. Let's see if we get the happy Mac face flash up like the other one. Yes and no. I've got Ethernet, just not very long. Let's just see if we see a happy Mac face. There we go. So yeah, this is going to be working. This is now doing exactly the same as the other board. So we'll get that SD card fixed up, and then we can boot them too. So that's, even though we haven't seen it go into the Mac OS, we know it's working now. So that is 2 fixed now. So we've got this one fixed, this one fixed. I've got a GoTech as well. I've got quite a few GoTechs, but I could do with one that already just plugs in and set up. Where would I plug the Ethernet cable? Or you mean into the Pi SCSI? Yeah, I see what you mean. If you can send me just an image, I'll do it later. I'll reflash the SD card. Or if you let me know, yeah, just send me an SD card. Basically, that's the simplest thing for them. So these 2 are fixed. A third one now. Obviously, I'm going to do this in another stream. I want to go get some food and drink and have a day where I'm not working all day, as well as I've got to get stuff ready for tomorrow's work. But maybe Monday, maybe Tuesday. Mondays are quite manic. I'll be back on this. The fact we've now got 2 fixed is ace. This third one, what happened with this was, in between swapping the SCSI over to this board that was dead, hence that issue we've just found, because when we swapped him over, we screwed this one up. This was fully working, just like this. We got to that, it went up to Mac, it corrupted and closed, and we thought it was this board at the time. So this was fully working. I reflowed pins here. Ooh, have we got the exact same issue? Let's just really quickly check we haven't got the exact same issue on this reloaded board, because that would be ironic. All we did was reflow the SCSI chip and then nothing worked, but I mean literally nothing. We didn't even get boot. Like, we get no diagnostics coming out of this. This is like as if the system's completely dead. No, they look fine. We'll punch in a bit more. Yeah, but what I am going to do is, we'll probably, when we come to fix this, we are definitely going to start, because they haven't tented the vias again. They're exposed. So what's the betting? I could almost guarantee you we're going to find a similar issue on the underside of this. We're going to look around like the VIAs. So over here, and I bet we're going to find a VIA. Like, it'd be nice to see the exact same problem. But this is definitely going to have a big visual inspection before we start. So yeah, what happened was we had this fully working. We thought it wasn't because of the SCSI. We reflowed the pins up here, and then everything stopped. You don't get boot, you don't get chime, you don't get diagnostics mode. It's as if this board is totally dead. I've checked all these chips work, all the socketed ones. We know everything else did work, like the whole system worked. There was no issue with it. And now there is. We've got working chips here that we can put on, so we know basically the chips are good, but this just seemed to die when we were up in this area. Just literally, I was just reflowing pins down here with an iron. So it's a visual inspection, I think, on this one, and maybe we'll find something else. I think I'll put back on the working chip here, and maybe we've got working ones here with green dots on that have been swapped around, so we know these are all good. I might even, for good measure, just take off the chips off one of these. So putting 3 known good chips on. But we can leave them off because the system should boot to cursor without this anyway. And I'll just put these on. But either way, that's the next one. And hopefully we can get all 3 working. And then I've got a stack of Macs. One can go back to the customer. I've got a few spare for when I repair them in the future. So that's it for this one, guys. Thanks for joining in nice and early. And what time are we even on? It's not even 9 ace. So I'm going to go get a Costa, get some food, and then I don't think I'll be back on later. I think it'll be Monday or Tuesday, but you never know. Twitch and Kick both seem to be an issue streaming on this, so I'll probably do try and go live on Twitch just to test if it streams, because I think it was the same yesterday. If I go to twitch.tv, even though I'm logged in and it shows us live, it just says this video can't be downloaded like I get. If I go to here and put on screen, I'm just getting this on mine, which I presume everybody else's just doesn't seem to work. So not sure why, but I'll fix that up. Try to get the streams working, but at least Facebook and YouTube seem to be solid, and TikTok seems to be. A few people mentioned the audio on TikTok. Well, one person mentioned the audio on TikTok has echo. I don't know whether it shouldn't do. It's the exact same stream. So I think 3 streams are working, and we just have to work out Kick and Twitch that aren't working, which should have been the simple ones. So that's it, guys. I'll catch you in the next one.